Cross entropy is the measure of how surprised, everything is in the terms of surprise only, surprised we are on an average if truth is P is the distribution, and we measure or we predict using Q. Okay, so P and Q are different distributions. So this is, as I mentioned, actual surprise from our model's prediction. We don't know what is the underlying distribution of the data, but we have our model which is telling that this is the distribution, and we try to predict the values. And that's where in the models we use this cross entropy loss a lot. You must have heard, you will in the further videos and machine learning, people who know that they use cross entropy loss. Okay, and this is the cross entropy, what type, this is the meaning of the cross entropy loss. Okay, so how's it given? So let me write it down. So this is given as h of p comma q. Okay, so this is h of p comma q. The actual probability distribution is p, and I am measuring it, trying to predict it using q. What is the measure of the surprise? So average again, so this will be expected value of, so I am measuring it using q. So the surprise will come from here, qx, and this is my, so this is my cross entropy, and this actually the distribution of x is coming from p. This is my actual distribution, and this is my surprise factor. This is my surprise. And what is the expected value formula again? This is equal to summation over, negative will come out, negative will take it out, I equal to 1 to 1, all the values what I have, probability of x into log of q of x. Okay, so let me write it I, so that because I is, I have mentioned I here. Okay, this is my I, this is your cross entropy. This is the, in terms of entropy, this is the how we write it, entropy of P when we measure it using Q. The underlying distribution is P, but I am measuring it using Q. So the surprise will come from Q, and the probabilities will come from, this is the probability of all the individual events in the distribution. Okay, the random event. So let me give you an example to understand this. Okay, so this is the definition. I hope the definition is clear. This is your cross entropy formula. Let's see the example. For example, okay, let's see, we have a model which is used to classify images as simple cats and dogs. Okay, a model to classify images as cats and dogs. Okay, so if I so for an image, okay, for an image, say if it is an image of a cat, so what will be my outcome? The true distribution will be probability of a cat. Okay, the true images is cat. So the distribution will be, how will the distribution look like? Distribution P will be equal to 1.0 for cat, or 1 for cat, and 0.0 for dog. So this is my original distribution. I know that this is 100% cat because this is how I have labeled, and this is 0% dog. Okay, and let's see how compare, okay, two models, okay, cross entropy of two models, which will give me the idea of cross entropy loss. Okay, so I have two models. So the first model output is, so first model is model A. Okay, and for this the output Q of A is that it is 0.8 cat and 0.2 dog. So this is what it is predicting, that cat is this and dog is this. See, this is my prediction, this is the probability of that. This is telling, originally we know it's 100% cat, but my model says that 80% cat and 20% chances that it's dog. That's how models predict. So now what will be my cross entropy? What will be my cross entropy for this? So actual, this is my actual P and this is my model Q's prediction. So this is the actual prediction, okay, and this is my model Q's prediction. So let's see what is the cross entropy. This is the actual entropy, this is the predicted entropy, and let's see what is the cross entropy, actual versus predicted. So how will we write it? H of P comma Q of A, this is equal to sum of all negative summation P of X log of Q of X. Okay, this is the formula. So what will be H of P comma QA? I'm writing it now. So there are two possibilities, cat or dog. So let me sum it up, minus. So actual probability of cat is 1 into log of, what is it predicting? This model is predicting 0.8 plus other option would be, what are the options? That it might be a dog, that is with 0 probability, that's the actual probability. So P of X is, that is the actual probability coming from here, 1 for cat and 0 for dog, and this is the predicted, this coming from 0.8 from here, and for dog it is 0.2. Okay, so this is 0 into log of 0.2. This is my negative outside common to all. So this will be equal to, so this is 0. So this will make this whole term 0. So only thing that remains is 1 into log of 0.8, that with the negative sign. What is log of 0.8? Log 2 base 0.8. So this is minus 0.32, and with the negative sign it becomes plus. So this will be equal to 0.32 bits, negative plus negative. So this is your HPQA. This is your model A. Okay, this is very low cross entropy, because we know that it is very close. It is 100% cat, 0% dog, and my model is predicting very close that it is 80% confidence it is telling that this is cat and 20% is telling it's dog. So this is very close to the actual. So that's why the difference, the cross entropy between the actual and the predicted is very low, and the model is doing pretty fine here. Okay, and the model is not surprised that okay, what I have predicted and what is the actual thing, it is differing by much. And now let's see, there's a model B. There's a model B which is predicting that it is 0.2 cat and 0.8 dog. Opposite, this is cat and this is dog. Let's measure the cross entropy of this now. This model is saying that this is 20% cat and 80% dog. Okay, actual is 100% cat. What will be the cross entropy? Let me write it directly. So H of P comma Q of B. So actual, so this will be negative of, so actual probability is 1 into log of 0.2 plus actual probability is 0 into log of 0.8. Directly I have written the formula. This is the probability of cat, this is the probability of dog. Is 1 and this is dog's probability. So minus, okay, all is log 2 base 2. Okay, so that's implicit, everything is done. So this will be, if you see this right, so this will be equal to log 2 of 0.2 is minus 2.32. This is minus 2.32. Minus minus plus, so this will become 2.32 bits. If you see here, the cross entropy is very high. This was only 0.32 bits and this is 0.32 bits. This is far off from the actual prediction, from the actual truth. So the surprise is very, very high for what is actual and what I predicted. So the net average surprise for the difference between these two is very, very high. The model predicted that it is a dog with a high probability, but that is wrong. So that's why we're getting a very high cross entropy loss, and this value will be fed back to train the model so that we reduce this. Okay, I hope cross entropy is clear.